you are just heading to a particular place and you find a question on your way, and you have to do the question and get the answer for a student who is waiting for the answer to the question. And this is what we have from logarithmic notations. I have been told that x power x. So that means this is an index notation. So x power x less log and 81 to base 3, and this is squared, and this must be equal to 0, where the whole of this part is getting raised to the logarithm of 256 squared to base 4. So just imagine you have been given this question by a student to get the answer. So I think what I'm going to do first, I'll be able to just take the whole of this logarithmic writing to this other end of the equal sign, because this is an index notation. So I'll write down x power x is now equal to, what I have here is 0. Then when all this is taken to this other side of the equal sign, it will be able to end up becoming plus. So I'll actually write plus the logarithm of 81 squared to base 3 getting raised to the logarithm of 256 squared to base 4. Let's try breaking this down, and of course we shall write and say x power x is still equal to, when this is added to this, it will remain the same thing. So the logarithm of 81 squared to base 3, and the whole of this is requested to actually able us get the answer when it gets raised to log 256, which is squared, and that is actually to base 4. So we shall proceed. We shall still come and say x to power x is equal to, then we shall drop this power, so we shall have 2 log 81 base 3, then this is raised to 2 log 256 to base 4. I'm just dropping these powers to this other end, so that the powers that have actually been given here can become the coefficient of these logs, both the base and the power. So we shall now rewrite and say x power x is the same as 2 the log of 3 power 4 to base 3. That is very correct, because 3 power 4 is 81, and this should be raised to 2 the log of 4 power 4, and this is to base 4. That's very correct. And we shall still be able to proceed and have the following. Again, the powers getting dropped in that case. So I'll have x to power x being equal to, so I'll say 2 times 4, because if this 4 drops, it will just be the same as 2 power 4 in the log of 3 to base 3. And this is raised to, again, you can drop this 4 as well. We shall have 2 multiplied by 4 and the logarithm of 4 to base 4. And we shall be able to proceed. I know very well in mathematics, as you know well, we can have x power x, okay, being able to be equal to 8 and the logarithm of 3 to base 3, correct? And this is raised to 8 as well, and the logarithm of 4 base 4. I was told by my teacher that the logarithm of a number to the base of the same number, the answer is 1. That means the logarithm of a to base a is 1. Or you can as well be able to say the logarithm of 10 to base 10, the answer is 1. So I'll actually apply that law here, or that identity of logarithms here, whereby I'll be able to say that x power x should be equal to 8, and of course logarithm of 3 to base 3, the answer is going to be 1. So 8 into 1. Then of course I'll write 8 as a power. Then the logarithm of 4 to base 4, the answer is still 1. So that you can be able to have now x power x being equal to, as you can see, 8 times 1, that is 8. Then as well 8 times 1, that is 8. So that is x to power x is equal to 8 to power 8. That means x is equal to 8. And that becomes your final answer for that question.